All right, so let me kind of walk you through the circuit and what we are trying to show here, right? So this is a half bridge circuit. There are two of them. There is one on the bottom, one on the top. They're exactly the same. The only difference between them is the connections, right? So this one has MMCX connections. The one here has square pins on it. Yeah. You can power them on. They're completely isolated and they have nothing to do with each other, but they're exactly the same circuit. The schematic is exactly the same. Okay. The way this works is you get power through your USB, so 5 volts, right? And this powers your power supply, or the circuit that takes this to 50 volts, right? So the VDS signal here should be 50 volts, and the VGS signal, the gate signal, is about 5 volts. Okay. What I have connected right now is an ISOView TIVM probe that is looking for the gate signal on the high side, and we should expect a switching signal at about 5 volts, right? So we are going to look at the rise time, the fall time, the Miller plateau, the performance, the dV by dt's and di by dt's of both, right? You can also measure current right here using the same shunt, but right now we'll just focus on the gate. Okay. All right, so that being said, this is how it's set up, right? So it has the 25 volts. We are at the 50 volts range, so we can measure VDS as well as VGS, right? Or we can do the 25 volts if we were testing the gate voltage, right? That's the main unit, right? And that's how it's connected to your scope, the MSO5 scope. All right, so now you can see I've triggered on 2 of the pulses. These are the VGS pulses. I don't know if you can read the scale here, but they're about 4.5-ish volts. Okay. Now, if I zoom into this right here, you can see there is a rise time, there is a slew rate, fall time, falling slew rate, right? And frequency is right there. That's your period, maximum voltage on that signal right there, right? So about 5 volts, and that's the amplitude and the area under the curve, right? Now let's kind of zoom into this and see if we can get rid of this light a little bit so we can see it better. All right. So I'm gonna start triggering on the fall time first. See if we can capture that. All right, that's good enough. And then move this guy a little bit here and bring it in the center so you can kind of see it. All right. Okay, so nice and crisp. You can kind of see the voltage dropping off, and then obviously you can move the cursors, right? So I can move this cursors right here to see your 3 dB point, and then all right. Okay, and depending on where you want to, this should not change the fall time measurements on the signal. So cursor says independent of your fall time. This is based on the calculations that scope makes. So don't worry about affecting this by trying to play with the cursors, trying to see what's happening in the events. Okay. All right. So that's your fall time. I'll focus on the rise time now. All right. So let's bring the scale down and change the trigger to the rise slope, and then we'll increase the scale again. Now this is a cool part, right? So you can see the Miller plateau and stuff. Let me just set the trigger properly. And once that is set, what we'll do is we'll move this guy a little bit further so you can see this really nicely. All right, and oops, too big. All right. Okay, all right, there we go. Right, so take a look at that, right? So let me stop this for a second. So there you go. Okay, there we go. All right, so you can see the nice, really nice turn on. There is your VTH threshold voltage and the Miller plateau, and then it again turns on at the same time. If you have 2 probes right now, I could show you the current and how it reacts to this, right? So you can easily calculate your rise time very, very accurately, and basically go through all these measurements, right? So there you have it. That's your half bridge measurement. Hopefully that is helpful. All right, thank you.